There is energy in the ocean.
We're talking about the energy available in waves, tidal currents, and ocean currents. And here in North Carolina, we have a reasonable wave resource, and we also have the Gulf Stream.
It's a tremendous amount of energy, and it's always available. And in a world struggling with climate change, that's an appealing combination.
The really wonderful thing about marine energy is that it is located near population centers, and it's also available in places that might not have access to some of the larger grid scale energy.
But whether ocean energy is harvested to power a community or a few buildings, the reality is that tapping the energy of the sea is not easy.
These are multidisciplinary challenges. There's geotechnical, there's environmental, there's the hardcore mechanical engineering aspects of it. I spent my first 30 years of my career in the Coast Guard as an engineer and working in the marine environment. It's a challenging environment.
Saltwater corrodes. Materials wear out faster in the ocean. There's also biofouling, where barnacles and other organisms build up on devices. But the design and testing of ocean energy systems is ongoing, and it's transitioning from theory to reality.
We've had a lot of developments in some of the devices that might go in the ocean to harvest energy, and so they've gone from theoretical ideas on paper to actual test deployments.
All right, so let's bring it over to try and line up a little bit. Pin.
Aha, that's in place. It's working.
And this is one of the most promising systems for harvesting ocean energy.
All right, deploying in 3, 2, 1.
Pulling the device behind a boat simulates a deployment in an ocean current. So, what's the device?
So we're at Lake Norman right now. We're here for tow testing of a 10th scale underwater energy harvesting kite.
That's right, a kite. It looks like an airplane, and there's good reason for that. The kite generates power by flying in the water, but it's the flight pattern that makes it all work. It's all about physics. Watch what the kite does during an earlier pool test.
So basically the idea is you take a high lift to drag wing, we call it a kite, and you fly it in figure 8 or elliptical patterns perpendicular to the prevailing flow. And as it turns out, if that kite has a high lift to drag ratio, it can fly many times faster than the prevailing flow speed. And what that means is you get significantly more bang for your buck.
By flying in that figure 8 pattern, the water moves over the wings at a much faster speed. That makes for a stronger pull on the kite, and that means more power can be generated.
So cross-current flight is where you're flying perpendicular to the prevailing current. So if your current is coming in towards your kite, instead of aligning it with the flow so that it just kind of sits there, you actually lean in and you fly patterns in that cross-current. And by doing that, you use that cross-current to generate lift, and you can fly perpendicular to it and go much, much faster than that prevailing flow. So if you got a current of 1 meter per second, you can actually fly that kite somewhere between 3 and 7 meters per second, depending on how it's performing. And by doing that, you generate a lot more electricity with a much smaller mass than will be required for a similar fixed space turbine. Pitch in 3, 2, 1. So there are 2 main ways that kites generate power. One's called ground gen, one's called fly gen. So ground gen, which is what we're using on this system, is that kite is attached to a string just like the kite you'd fly at the beach would be. And so by generating all that force from flying that figure 8 really fast, you actually can spool out that winch, and there's a generator on the winch harnessing all of that force that you're spooling out with.
All that power is used to spool and unspool a cable. The cable is turning a turbine, and that generates power.
The other way that kites generate power is something called fly gen, which is where instead of spooling out a winch, you fly at a constant tether length, and there are turbines on the kite. And so you're just flying that pattern faster than the prevailing flow, spinning the turbines and generating electricity on board and sending it back through your string up to some sort of battery.
We change the design of the kite depending on the application. So for example, it might be harvesting current energy from the Gulf Stream, where the ocean currents are relatively swift, up to 4 knots or 2 meters per second, even 6. Or it might be in a tidal inlet where the currents can get up to 3, 4 meters per second, 8 knots, 6, 8 knots. Or it might be in the deep ocean where the currents are much slower. And so, for example, if we're developing a kite to harvest energy in the Gulf Stream, the kite might not have turbines on the wings. The kite might generate energy by being on a tethered winch. If you're putting the kite in the open ocean where the currents aren't that strong, then it's more efficient to put turbines on the wings.
Kite systems could eventually be scaled up to power entire communities. But for now, researchers want to test the kite system by powering navigational instruments like buoys. Kites can also power oceanographic science systems deployed in the ocean.
We're not quite scaling up to what we call maybe grid scale, which would be how can we put something in the ocean and power all of your homes, right? At this point, we're looking more at niche applications, like how could I put something in the ocean that would power this device to make observations for more than the 2 years that the batteries will do that.
But researchers say new discoveries are helping them build an industry that's labeled the blue economy, and they're building it from scratch.
So we've had successful deployments short term, and now we're looking towards some of the materials questions to build these things to go in the ocean for maybe a year or several months, and we're just making progress.
Thanks for watching. If you want more science stories like that, like us and follow us.